Iceland is not erupting because something went wrong. It is erupting because something irreversible has begun. Right now, magma is moving beneath the ground faster than scientists expected, not toward a single volcano, not even toward a single region. The ground is opening in multiple places at once. What you are seeing on the surface looks calm, measured, almost controlled. That is the illusion, because surface eruptions are not the event, they are the release valve. The real process is happening deeper, wider, and it does not reset. To understand what Iceland is entering, you have to stop thinking in eruptions. You have to think in fractures. And once that shift happens, nothing about this island looks temporary anymore. Iceland sits directly on top of the mid-Atlantic ridge, two tectonic plates pulling apart in opposite directions, North America drifting west, Eurasia drifting east. In most places on Earth, this happens silently beneath kilometers of ocean, out of sight, out of mind. But Iceland is different. Here the ridge rises above sea level, and the planet is literally tearing itself open in plain sight. That alone would explain frequent volcanic activity. But Iceland adds another force. Beneath the crust lies a mantle plume, a deep column of heat rising from far below the Earth's surface. Hotter than the surrounding mantle, persistent, relentless. The ridge pulls the crust apart, the plume pushes magma upward, pressure builds, cracks form, and eventually the system does what physics demands. It erupts. But this is not where the danger begins. This is only the mechanism. The real story begins with timing. For centuries, Iceland appeared relatively quiet by its own standards. Eruptions occurred, but they were spaced out, localized, manageable. Then something changed. Around 2020, seismic activity increased in ways that did not fit older patterns. Earthquake swarms became more frequent, more shallow, more persistent. Magma intrusions were detected migrating sideways for kilometers beneath the surface, not feeding a single volcano, but entire fissure systems. This matters, because Iceland does not erupt like a classic stratovolcano. It does not rely on one central cone. It opens, long cracks tear through the ground, lava spills across plains, roads are cut, infrastructure is swallowed, and crucially, these eruptions can repeat again and again from slightly different locations. This is not a single event problem, it is a system problem, and scientists are now increasingly confident about one conclusion. Iceland has entered a new volcanic phase, but that statement carries far more weight than it sounds. Iceland's volcanic history operates in pulses, long quiet intervals, then centuries of elevated activity. The last major active phase began around the year 800 and lasted for hundreds of years. During that time, lava flows reshaped large parts of the island. Ash clouds disrupted agriculture across Europe. Entire regions were abandoned. Then activity declined, not stopped, declined. What we are seeing now aligns disturbingly well with the early stages of that earlier phase. Geochemical signatures match, eruption styles match, the spacing between events matches, and perhaps most importantly, the magma supply rate appears to be increasing. More magma moving upward means more frequent eruptions, but it also means something else. The system is no longer fully resetting between events. Pressure does not completely dissipate. Pathways remain partially open. Each eruption makes the next one easier. This is why recent Icelandic eruptions appear calm on camera, yet deeply concern scientists behind the scenes. Because calm lava does not mean a calm system, it means the crust is yielding. And that raises a critical question: how long can this continue? One of the most misunderstood aspects of Icelandic volcanoes is explosivity. Slow-moving lava creates a sense of safety, a false sense of control, but Iceland has a second personality. When magma interacts with ice or water, the equation changes instantly. Steam expands violently, rock shatters into fine ash, eruptions turn explosive. Iceland is covered by glaciers, and some of its most powerful volcanoes sit directly beneath them. When those systems activate, the effects are not local. Ash clouds rise into international flight corridors. Fine particles spread across continents. Sunlight is blocked. Weather patterns shift. This is not theory. In 2010, a single eruption shut down European airspace. Millions of passengers stranded, global supply chains disrupted, and that eruption was moderate by Icelandic standards. The real concern is not whether Iceland will erupt again. That is guaranteed. The concern is where and under what conditions, because the next eruption does not need to be larger to be far more disruptive. Iceland's magma systems are not isolated chambers. They are interconnected networks. Think plumbing, not storage tanks. When magma moves in one region, stress is redistributed elsewhere. This means eruptions are not independent events. They communicate. Recent data suggests that intrusions in one area may increase the likelihood of activity in neighboring systems, not immediately, but over time. Stress accumulates, faults weaken, pathways align. This raises the possibility of cascading activity, not simultaneous eruptions, but sequential ones. One system waking up because another already did, and history supports this concern. During Iceland's last active phase, eruptions clustered far more tightly in time. Decades of relative calm followed by bursts of repeated activity. That is the pattern scientists are now watching for. Not one eruption, but shrinking gaps between them. What makes this phase different is not just how often Iceland erupts, but how little time the ground gets to recover. In past centuries, weeks or months could pass between major intrusions. The crust had time to cool. Stress redistributed slowly. That is no longer happening. Satellite measurements now show continuous deformation. The ground rises, pauses, then rises again. Not reset, not release, just accumulation. This tells scientists something crucial. Magma is not simply arriving, it is lingering. When molten rock remains close to the surface, the threshold for eruption drops dramatically. Small triggers become enough. A minor earthquake, a pressure shift, even seasonal ice melt. And this is where prediction becomes difficult, because the system no longer behaves like a single volcano with a clear warning phase. It behaves like a stressed fault network waiting for a weak point, which means the next eruption may not come from where the last one ended. It may come from where nobody is looking, and that uncertainty is far more dangerous than spectacle. There is also a quieter signal that rarely makes headlines. Gas. As magma rises, it releases sulfur dioxide and carbon dioxide, invisible indicators of movement deep below. In recent years, these emissions have increased even when no eruption followed. That suggests magma is stalling just beneath the crust, close enough to affect chemistry, not yet close enough to break through. This is one of the most unstable states a volcanic system can enter. Too shallow to ignore, too deep to relieve pressure safely. And Iceland is not dealing with one such zone. There are several, spread across the island, each one capable of activating independently or in sequence. This is why volcanologists are no longer focused on dramatic explosions. They are watching continuity, how often magma moves, how long it stays, how quickly pathways reopen, because the danger is not a single catastrophic event, it is persistence. Modern Iceland is not medieval Iceland. It is wired, connected, dependent on infrastructure that did not exist during previous volcanic phases. Power plants, data centers, fiber optic cables, international shipping routes, air traffic corridors. Iceland sits at a critical junction between continents. Disruption here does not stay local. A single eruption can ground flights across half the planet. Repeated eruptions can reshape global logistics planning. And unlike earthquakes or storms, volcanic unrest does not follow clean timelines. It escalates, pauses, returns. Communities cannot simply rebuild and move on. They must live with uncertainty. This is why Icelandic authorities are not asking if eruptions will continue. They are planning for how often and how close together. Because once a volcanic system enters an active phase, it rarely switches off quickly. The idea that scientists are caught off guard is a misconception. What is happening in Iceland was not predicted in detail, but it was expected in principle. The data has been pointing this direction for years. Seismic activity, ground deformation, gas emissions. all signs of a system reactivating on a large scale. What is new is the pace. Magma is moving faster, eruptions are occurring closer together, public visibility is higher than ever, which creates the illusion of sudden chaos. In reality, this is a long geological story entering its next chapter. Iceland is not becoming more dangerous, it is becoming more honest. Honest about the forces beneath it. Honest about the cycles it cannot escape. The island is doing what it has always done. The difference is that this time, the world is watching. And the next eruption, whenever and wherever it happens, will not be an anomaly. It will be a continuation, but that was only the beginning. Stay curious, stay aware. This is SeismoSphere,